Welcome to this analysis. The next time you're walking through a park, you might actually want to listen just a little bit closer. Today we're stepping into a completely hidden world. It's happening right under our feet, right above our heads, and literally all around us, and yet we are almost completely deaf to it. We're going to be exploring some truly mind-blowing scientific discoveries about animal communication. We're looking at data that completely shatters the old idea that animals are just out there making random noises. Instead, we're looking at highly structured, incredibly complex systems of information exchange. They aren't just making sounds, they are actually talking.
Okay, let's dive into this. A tall, thin, yellow-furred coyote is approaching rapidly. It sounds exactly like a text message a scout might send over a radio, right? It's highly descriptive, it's urgent, and it's incredibly specific. But here's the wild part. This sentence wasn't spoken by a human. It wasn't typed out by some field observer. This exact level of detailed information is actually being broadcast by a tiny animal living underground.
Section 1. The Secret Language of Prairie Dogs, Decoding Underground Transmissions.
Now, what's really interesting about this slide is the sheer depth of the data. For over 30 years, Professor Konslobodchikov out at Northern Arizona University has been analyzing the high-pitched squeaks of prairie dogs. To us, if you walk past a prairie dog town, it just sounds like a generic panic alarm, right? Just as simple, hey, danger is here. But look at the exact breakdown of data embedded in just one single call. In a literal fraction of a second, that little squeak encodes the species of the predator, the size of the predator, the color of its coat, and the speed at which it's moving. So when that coyote approaches, the prairie dog isn't just saying, look out. It is specifically communicating that a tall, thin, yellow-furred coyote is approaching rapidly. It's just incredible.
Section 2. What are birds really saying? Threat levels and hidden acoustics.
Let's pivot our focus from the ground up to the sky. Dr. Michael Greischer at Uppsala University discovered that Siberian crows are essentially running a highly sophisticated surveillance operation. Picture this. A hawk enters their territory. The threat isn't static, it escalates. First, the hawk is just perched in a tree. It's there, it's a threat for sure, but it's stationary. Then it takes flight. It starts actively hunting, scanning the ground. And finally, it locks onto a target and drops into an attack dive. Dr. Greischer's research shows that these Siberian crows don't just use one generic panic squawk. They use completely distinct alarm calls for each of these three specific states. They literally have a specific word for perched hawk, a totally different word for hunting hawk, and an urgent, distinct word for attacking hawk.
And the complexity just scales up from there. Look at this massive number, 50. Dr. Eric Green and Dr. Chris Templeton from the University of Montana discovered that the tiny black-capped chickadee actually utilizes 50 distinct, unique calls. And honestly, the most fascinating part? Most of these calls contain differences that are so minute, so incredibly subtle, that the human ears simply cannot distinguish between them. We physically cannot process the data they're exchanging.
This brings us to a pretty profound realization, perfectly summarized by Dr. Adam Fishbane from the University of California. He notes, birds appear to pay more attention to fine acoustic details humans cannot hear than to the melodies that fascinate us. For centuries, we humans have written poetry about the beautiful songs of birds, kind of just assuming they were singing pretty melodies for us to enjoy. But the scientific data points to a very different reality. They aren't singing for us, they're talking to each other, communicating in a high-definition acoustic space that our ears aren't even equipped to enter.
Section 3. Seismic Vibration Networks of Elephants. 2 channels of communication.
And this brilliantly illustrates just how massive the scale of this communication can get. At Harvard University, Dr. Caitlin O'Connell Rodwell made a groundbreaking discovery about these massive animals. Elephants don't just use their vocal cords. As they make those low-frequency airborne calls, they simultaneously generate massive seismic waves that travel thousands of meters underground. This is an absolute engineering marvel. Elephants literally feel these seismic vibrations through their feet. They're communicating on 2 entirely separate channels at the exact same time, an airborne audio channel and an underground seismic channel.
Section 4. Who taught these languages? The philosophical pivot.
This is where our source material asks us to dramatically slow down and transition from observation to deep reflection. Think about the sheer scale of what we've just covered. Not a single one of these animals attended a language school. None of them learned an alphabet. Yet they transmit highly complex data about color, size, speed, and threat levels right from birth. The author of our source text presents a very logical interrogation here. If human language, with all its words, grammar, and meaning, requires an intelligent inventor, are we supposed to believe these complex animal systems formed entirely out of nowhere?
Looking back at the specific scientific marvels we just decoded, the source material poses these direct rhetorical questions. Who created the intricate vocabulary of the prairie dog? Who instructed the Siberian crow on the precise moments to use 3 completely different acoustic warnings for an escalating hawk threat?
So, the crucial point is that the source material fundamentally raises the question of intelligent design. When an elephant sends a dual-channel broadcast through the earth and the air, and another elephant receives it miles away through its feet, well, who designed those seismic vibration sensors? The text argues that the sheer helplessness of these animals at birth, contrasted with their highly sophisticated built-in technology, points to an external designer.
Section 5. Creation and the Language of Birds. The source material's conclusion.
To answer the profound mysteries raised by this data, the author's conclusion asks us to consider a theological lens. The source material presents this verse from the Quran. We have been taught the language of birds, from Surah An-Nam, verse 16. The author uses this as the ultimate answer, framing the 50 hidden acoustic calls of the chickadee, the 3 distinct alarms of the crow, and the incredibly detailed descriptions of the prairie dog, not as evolutionary accidents, but as deliberate creations.
And the text leaves us with this final definitive statement. These are languages, and the creator of that language is evident. The author invites us to look at the data, this undeniable structured communication happening all around us in the animal kingdom, and see it as clear evidence of a conscious creator. It is a fascinating intersection of rigorous natural science and deep philosophical meaning. So what does this all mean for how we view the natural world? I'll leave you to reflect on that for a moment.